Welcome to chemistry. Today we're going to be talking about electronegativity, and I'm going to write what it says on the slide there, and that's the definition of electronegativity. Electronegativity measures the relative strength with which atoms attract valence electrons in a chemical bond. This is an arbitrary scale from 0 to 4, just like the 4.0 grading scale is arbitrary as well. A 0 being an F, that's a low number, and a 4 being an A, that's a very high number. So I have highlighted in black and white some electronegativity values on the periodic table for some select elements. So I'm going to point out a few of them for you. Here is fluorine. Fluorine is the top dog in that it has the highest GPa, the highest electronegativity value of a 4.0. And going down from hydrogen, you should see that oxygen is the second most electronegative element at 3.5. Then we have chlorine and nitrogen sharing the same value of electronegativity, and that is 3.0. And then also carbon and sulfur sharing the same value of electronegativity, that is 2.5. You should notice the trend here. Hopefully recall the trend in size of atoms. But this trend of electronegativity in a group, going down a group is decreasing in electronegativity, and going to the left within a period is decreasing. Think about that in terms of size. Okay? I'm going to highlight another section here, and this is hydrogen on the far left-hand side. It has an electronegativity of 2.1. It's very unusual because that's not really where hydrogen should be placed on the periodic table. But in looking at the rest of group 1, look at how the numbers start to decrease all the way down to cesium. So that is going from hydrogen to cesium, it decreases in electronegativity. So the general trend for electronegativity is opposite that of the trend for size of atoms or size of ions, if you recall from that prior knowledge lesson there. Okay, so as I go up a group, the electronegativity value increases. And if I go to the right across a period, the electronegativity value increases. And that is the general value of electronegativity is going up, and to the right it increases, with fluorine being the most electronegative. So these electronegativity values are going to play a crucial role when we do Lewis dot structures. So think about that. I'll see you next time.